Q3 says NR is defined as the ways of selecting R distinct objects from a given set of N objects. From the definition, show that NCR is equal to N minus R. Now, to do this question now, so we need to prove that N choose R is equal to N choose N minus R. Now, in order to do this, what we're going to be doing is we have to go back to, we have to go back to combinations. Yes, we need to go back to combinations. So remember, NR is really N choose R, right? And N choose R is equal to N factorial divided by N minus R factorial times R factorial, right? That's what it is. Yeah, man. Now look what I'm gonna do right here. So now this can be written as, I'm gonna change the color here. This can be written as N factorial over, this is now N minus, in bracket, N minus R, close up that bracket, factorial, multiply by N minus R factorial. And I'm going to explain what I just did. What I just did was, you see all of this right here, so it's really R factorial, you know. All of this here, so R factorial. So all I really did was rewrite R factorial as N minus R. Because if you look at it, N minus R is N minus N plus R. But all of that is R factorial. But then this is what? This is now N factorial over, this is now N minus R, and this is N minus R. So all of this really works out to be N choose N minus R. That's how you do this proof. So that's that. That's the 2 marks right there. So that's the first one, part I. That's our 2 marks. Okay, nice. So we're going 2 marks now. The next part, it says we're supposed to prove that N plus 1 choose R is this right here. So we need to now prove N plus 1 R. We need to show that this is equal to, what was that again? N choose R plus N choose R minus 1. N choose R plus N choose R minus 1. So now, of course, what I like to do is write down what we're going to try to prove in combinations. This left-hand side over here, what we really want to prove is that N plus 1, we want to prove that N plus 1 factorial over, this is now N plus 1 minus R factorial times R factorial. We want to show that this is going to be equal to N choose R, which is N factorial over, this is now N minus R factorial times R factorial plus, this is now N factorial over N minus, this is N minus, in bracket, R minus 1 factorial times R minus 1 factorial. So this is what we want to prove. All right, so we want to prove that this side, we want to show that these two are equal. All right, now when you're doing proofs, you usually need to prove that the left is equal to the right. All right, so we need to show that the left side is equal to the right. You don't show the right equal to the left. So let's do this on a fresh page. Let's start with our left-hand side. So our left-hand side, we start by saying this is equal to, let me write it down again, our left hand side is n plus 1r. You have to start with your left hand side. You don't prove from right to left, you prove from left to right. So we have to start with n plus 1r and write, so this is n plus 1 factorial. This is n plus 1 factorial over, this is now n plus 1 minus r factorial times r factorial. That's where you start with. Now let's look back at what we are trying to prove. We are trying to prove that this part right here says really n minus r plus 1. N minus r plus 1. Yeah, man, that's n minus r plus 1 or n plus 1 minus r. So now what we're going to tell them say is this to the part here. We're going to tell them say we can break this up as, we're going to tell them so we can write this as, you know, remember you do partial fraction? With a partial fraction, let's say it can break up as a over, put backward this denominator, a over n minus r times r factorial, n minus r factorial times r factorial, plus b over, round here so now is n minus, you can write this as n plus 1 minus r factorial. This is n plus 1 minus r factorial times r minus 1 factorial. So what we're telling them is that we can break up the left-hand side as two fractions. So now we just need to use like partial fraction to find a and b, but we know a and b is supposed to work out to be n factorial each. So how we do that now? So first we draw the line to make them one fraction now, and the common denominator is n plus 1 minus r factorial, r factorial. Yeah, man, that's the first thing. Draw a little line. Yeah? Yeah, man, we have to have fun with it. So now we're going to say n minus r into this into this. If you look at it, what you're really dividing is n plus 1 minus r factorial over n minus r factorial. But if you think about it this way, how I want you to look at it is, if let's say n minus r, this not really look like n, so come and fix this up. If you have n minus r factorial, right? Think of n minus r as 5. If you have, let's say n minus r did equal 5, then that means that n minus r plus 1 would have equal 6. Now, if you divide 6 factorial over 5 factorial, you'd just get 6. Check it in your calculator, you'd just get 6. So what am I trying to say? I'm trying to say when you divide this by this, you just get what's in the numerator, but drop off the factorial sign. This can become a times in bracket n plus 1 minus r. Close up the bracket there now, plus b times, no, this into this cancel, but r minus 1 factorial into r factorial, that just leave r. So get b times r. So now we're nice, we're nice. What do you mean we're nice? What do I mean by we're nice is now we can solve for a and b by equating numerators. Now we can just equate numerators. By equating numerators, by equating the numerator them, what we're going to get now is n plus 1 factorial. This part here, so now we're getting n plus 1 factorial. Right, this is better. N plus 1 factorial. We're getting that this is equal to a times in bracket. This is really a times n. If you want to expand out, a plus n plus a All right, do I want to expand out? I'm just looking if I want to expand out, because what I realize I get is a plus n plus a minus ar plus br. All right, this is what I end up get. That's by equating the numerators. Now on this side now, I notice what I can do is factor out my n terms right here, or my a terms. For factor out my a terms, I have a time, well, factor out my a from this part right here, I have a times n plus 1. And then I have minus r times, this look like b minus a. And I need to find out what is a and what is b. Now over here, so n plus 1 factorial, remember, it is really n times in bracket, or it's rather n plus 1. It's rather n plus 1 factorial, or n plus 1 times n factorial, like now continue. It's n plus 1 times n factorial. All right, so it's n plus 1 times n factorial. Now, let me see if I have an AR cancel somewhere. This is minus AR. All right, I factored out this now. So what this want to tell me then, but we know that this is supposed to be n factorial. All right, so look what I'm going to say now. Look what I'm going to say. All right, this is where math gets really nice. So right here, so now we're going to equate this part to 0, because no r not the over here, so this is plus 0 times r. Cool. So what this is telling us is equating this side and this side. What that is telling us is, let me box it off right here. What that is telling us then is a times n plus 1 is equal to, it's equal to, see there, this is now n plus 1 times n factorial. N plus 1 times n factorial. Then guess what happened? The n plus 1 factor, n plus 1 then cancel. So end up get a is equal to n factorial. Now equating now, we have 0 r here, so, and this is now equal to b minus a. So what we're going to end up getting is equating the r terms, then we'll have 0 r is equal to, it's really a minus b times r. All I did was push out the minus sign to be with the r then, so it worked out easier. So then this cancel this, the r then cancel on each side. So now we end up get 0 equal a minus b. But guess what? We already said that a equal n factorial. So when we transpose it, we're gonna get a equal to b. But a is equal to what? Yes, you rightfully said it. N factorial. This is nice though. So put a as n factorial and b is n factorial. So now we can tell them, say this now. I don't want to use up too much page, but no, this is not proper. So now we can finally tell them now. So it's now equal to, all right, well, left hand side, which is n plus 1, choose r. We can tell them, so it's now equal to, remember it is a over what? A over n minus r factorial, r factorial, plus b over, now pre-omega change up this now. What I'm going to do is, I'm not going to write this as n plus 1 minus r anymore. I'm going to write this as n minus r minus 1. I'm going to rewrite n plus 1. I hope you're following what I'm saying. I'm going to rewrite n plus 1 minus r. I'm going to rewrite that as n minus in bracket n minus r. That's what I say I'm going to do. I'm going to rewrite it as n minus r minus 1. Sorry, r minus 1. This should be a r minus 1. I'm going to rewrite that part as r minus 1. So I'm going to rewrite this part as n minus in bracket n minus r factorial times r minus 1 factorial All right, sorry about that. The Wi-Fi just chipped away, so I'm just gonna have to write it over that we end up get that n plus 1 choose r is, we end up get that it is n factorial subbing what was a over n minus r factorial times r factorial plus b now, where we got that b was also n factorial over n minus in bracket n r minus 1, this is a r, don't let it trick you, factorial, close up this, times r minus 1 factorial. And they will tell him, so of course this is now equal to, this is n choose r plus n choose r minus 1, which is equal to n r plus n r minus 1. So that's how to do this question. Yeah, man. Nice. That's how to do this. Yeah, man. So that's how to do this. So that's how to do that one now, and that take care of part 2. Now part 3 say hence prove that 8, 6 plus 8, 5 times 8, 3 plus 8, 2 is a perfect square. So just need to show us it's gonna work out to be a perfect square. So we have do the second part down here. Part 2, we need to show that 8 choose 6 plus 8 choose 5 8 choose 6 plus 8 choose 5. The result of this is going to be multiplied by, I think it's 8 choose 3 plus 8 choose 2. 8 choose 3 plus 8 choose 2. So the result is multiplied by 8 choose 3 plus 8 choose 2. I will need to use the result above to help us. All right, we need to use the result above. That's why it's a hence. Now, since it's a hence, we need to go back to this one right here. The first one, remember the first one said n choose r is n choose n minus r, right? Remember, n choose r. I'm gonna do it in burgundy right here. So I'm gonna write recall, n choose r is equal to n choose n minus r. Yeah, man. So just make up a number for n. Let's say n is 8 and r is 6. That implies that what we basically say is if you put n as 8 and r as 6, you're going to end up say 8 choose 6. It's supposed to equal to, if we plug this then as 8, you're going to end up get 8 choose 2. Because put the r as 6, you get 8 choose 2. So that means that 8 choose 6 is the same as 8 choose 2. Likewise, if you did put n as 8 and r as 5, 8 minus 5 is 3. So basically, 8 choose 5 is also equal to 8 choose 3. So what does that mean for us? That means, I'm going to borderline this off. That means this part now is equal to this over here, so is the same as this over here, so. So we can end up right, so this is now going to be equal to 8 choose 6, 8 choose 6 plus 8 choose 5, and it's going to be multiplied by itself. 8 choose 6 plus 8 choose 5, close up that, and it's going to be multiplied by itself, which is 8 choose 6, because 8 choose 3 is the same as 8 choose 5. Oh, I should have put a 5 right here, so boom, plus 8 choose 2. And anytime you multiply anything times self, you end up get a perfect square. So could I rewrite all of this as, just rewrite all of this, this is going to be 8 choose 6 plus 8 choose 5. By the way, this 2 should have been a 6 right here, so put 6. This is 8 choose 6 plus 8 choose 5 all square. So that's all. That shows it's a perfect square, because we'll end up getting all square. So it's going to be a perfect square. Nice. So no do not yet. That's it. Now let's do part B now. Dum dum dum. Now part B is that look like a combinations kind of question-ish. Now this one tell we say, find the 5-digit number. Find the 5-digit numbers greater than 30,000, which can be formed with the digits 1, 3, 5, 6, and 8 if no digit is repeated. And then part 2 say we're supposed to find what is the probability. All right, so these are what we have to do. First part and second part. So now find the number of 5 digits. Find a number of 5-digit numbers greater than 30,000, which can be formed within the digits 1, 3, 5, 6, and 8 if no digit is repeated. Number of 5-digit number greater than 30,000. So first thing, I like to do it by a box method. So what I like to do is draw a box first and foremost. I'm like to cut it in 5 pieces. 1, 2, 3, 4, 5. Why did I cut it in 5 pieces? Because it's 5 digits. That's why, 5 digits. So now it says, find the number of 5 digits number that is greater than 30,000, which can be formed from 1, 3, 5, 6, and 8 if no digit is repeated. So if it's greater than 30,000, then it can either start with 3, 5, 6, or 8. The number has to begin with 3, 5, 6, or 8. So that's 4 possibility right here. All right. So you have to say it. Remember, the number has to start with 3, 5, 6, or 8. So that's why we'll have 4 options right there. That's where the 4 come from. Then after we take out one number at the start, then you're left back with 4 numbers. So any number can go here, so then 3 number, then 2 number, then 1 number. And because these are all independent of each other, we need to multiply them across now. So the number of 5-digit numbers, that's going to be equal to work out the number of 5-digit number, it is 4 times 4 times 3 times 2 times 1. But we work that out now. 4 times 4 is 16. 16 times 3 is 48. 48 times 2 is 96. So there are 96 ways we can form the 5-digit number then that's going to be greater than 30,000. So just to put it in bracket, number of 5-digit numbers formed greater than 30,000. Just to make them to say no way there though. Yeah. Now it says, what is the probability that one of the numbers chosen? What is the probability one of the numbers chosen is even. So find the probability that the number formed is even. What's the probability that this number is even? Now first we need to look at how many numbers that are greater than 30,000 can be even. So first thing we have to draw a box again. We want to find the number of numbers greater than 30,000 that can be even. So first thing is we have to make the number greater than 30,000, right? But at the same time, it have to even, so it can either end with a 6 or 8. So put a 2 right here, so. Put a 2 right here, so. Why we put a 2 right here? So I'm write it in black. The number can either end with 6 or 8. That's why we'll put a 2 right there. So the number can either end with a 6 or an 8. Now that we established that the number can either end with a 6 or 8, we need to make sure it's greater than 30,000. So after our interest, we'll take out one even number. You have left back with 4 other numbers. The 4 other numbers that you left back with, you have to take out one, say put a 3 at the front. Why do we put a 3 at the front? After taking out a even number, we are left with 4 numbers, but the number at the start can't begin with 1. It can't begin with 1 if it's bigger than 30,000. So that left back with 3. Now we have 3, can put 9 mega, so 2 and then 1. So 3 times 3, 9. 9 times 2, 18. 18 times 2, 36. So the probability that the number chosen is even, that's going to be equal to how many even numbers are there? 3 times 3, 9. 9 times 2, 18. 18 times 2, 36. It's 36 over the total possibility of 96. That's the probability of getting an even number. Soft. That's about a 40% chance of getting an even number. That's not too bad. Nice. Now the next part says show that 1 minus I is one of the square roots of minus 2i. So we need to square root minus 2i, or rather we need to show that 1 minus I is one of the square roots. 1 minus I is one of the square roots of minus 2i. So in order to prove this, what you need to do is we can also prove vice versa. We can prove, in order to prove that this is true, we can prove that 1 minus I, when you square it, that should be equal to minus 2i. You can prove that too, you know? If you square both sides, this should be true. So let's work this out. So 1 minus I, when you square it, 1 minus I square, you're going to get first term square minus twice the product of the 2 plus the second term square. But I square is minus 1. So you're going to end up get 1 minus 2i minus 1, which is just minus 2i. And then what you're going to do is tell them since tell them now, since 1 minus I square, since 1 minus I square is equal to minus 2i, that implies if we square root both sides, that implies 1 minus I is equal to the square root of minus 2i. That's it. Nice. So prove it. All right. Nice. So didn't have to actually square root anything. Nice. That's just 2 marks. It says find the other square root. Now remember, the square root of numbers, the square root of a complex number occurs in conjugate pair. So the square root of complex numbers occur in conjugate pairs. They might say, what do you mean by conjugate pairs? That's crazy. What we mean by conjugate pairs is if you square root 1 minus I to get this, and the square root of complex number occurs in conjugate pair, what we're then saying is the square root of minus 2I, it's going to give you two answers. It's going to give you plus or minus in bracket 1 minus I. All right. So that means that if you put the plus, one answer you get is 1 minus I, or the next answer you get is minus 1 plus I. So minus 1 plus I is the other root. Minus 1 plus I is the other root. That's all that is saying right there. Nice. So the other root is minus 1 plus I. Then it says, hence we need to solve for the roots of this complex equation. I'm just going to copy it because who has time to work this one out? So let's copy this. So we have z squared. We have z squared minus 3z minus 3 plus 5iz plus 8i. This is what we have. We're going to solve this. Solving this, we're going to get z is equal to minus b, which is going to work out to be 3 plus 5i, and that is going to be plus or minus the square root of b squared minus 4ac. So it's plus or minus the square root of 3 plus 5i squared minus 4 times a, the coefficient of z squared is 1, times c, which is 8i minus 4, and this is being all over 2a, all over 2 times 1. So what we end up get is z is equal to, this is going to be 3 plus 5i, close up that bracket, plus or minus. Now what you're going to do is expand this square now. First term square, which is 9, minus twice the product of the 2. 5 times 3 is 15 times 2, that's minus 30i, plus second term square, that's plus 25i squared. 25i squared, I just write it down, 25i squared. And it's going to be minus 4 times 8, that's 32i. It's going to be minus 4 times minus 4, that's plus 16. And all of this, remember, is being square rooted. Don't dash away square root. And then all of this is being divided by 2. Now co-write a little bit tidier. So end up get z is going to be equal to be 3 plus 5i, 3 plus 5i, plus or minus, Now look at this now. You see this right here? So now I square, remember, I square is minus 1. So this is minus 25. But minus 25 plus 9 plus 16 gone. So the only thing left back right here, so it's just minus 2i over 2. But remember, that's why them say hence, because the square root of minus 2i, we know say it is 1 minus I. So it's going to be 3 plus 5i plus or minus. I write my item very weird. So it's plus or minus, this is in bracket, 1 minus I over 2. So there are two answers I get. I'm just going to put the answer there right here. The first answer is with the plus. You end up get z is equal to, follow me, 3 plus 1 is 4. So that's 4. And 5i plus minus I, that's plus 4i over 2. And if you want to simplify it, you'd end up get z is 2 plus 2i. That's one answer. Or there's another answer you can get. The next answer is, what if we did steal so boodoo and go with the minus 3 minus 1 is 2, so you get z is 2. Then you have 5i minus minus I, that's plus 6i. And then you divide this by 2. When you divide this by 2, we're going to end up get z is equal to 2 over 2 is 1 plus 3i. So it end up get z is 1 plus 3i. That's one answer that we get right there. Z is 1 plus 3i. All right, those are the answers. Nice. So get 2 plus 2i. It's one answer, 2 plus 2i. And the next answer we get is 1 plus 3i. Nice. And that takes care of question 5. Nice and easy, soft. Moving right along now, we see that this is a full matrices question, so we don't have nothing to worry about. Let's start with the first part, part A. You give us a matrix. A is this right here. Show that the determinant of A is 5. So can I copy these numbers? We shall see. So the matrix A is, I'm gonna write this a little better. I think this should be it. 1, 1, 1, 2, minus 3, 2, minus 1, minus 3, minus 2. That's it. Yes, that is the matrix A. So this is A, all right. This is the matrix A that we have. And they want us to show that the determinant of A is some number. So now we need to just work it out. The determinant of A is equal to, I'm going to be using row 1. So it's going to be 1 times the determinant of, I cross out the row and the column with this one. That leaves me back with minus 3, 2, minus 3, minus 2. Then I have minus 1 times the determinant of the row and the column with this one. Boom, boom. That leaves me with 2, 2, minus 1, minus 2. So that's 2, 2, minus 1, minus 2. Then I have the determinant of this last one, which is plus 1, times the determinant of, cross out this row and this column. That's 2 minus 3 minus 1 minus 3. So that is 2 minus 3 minus 1 minus 3. So I work this out now. So what I'm going to get is the determinant of A, that's going to be equal to product of the leading diagonals, that is 6, minus the product of the non-leading, that's minus 6. Close that. Then I have minus 1 times in bracket, product of the leading, minus 4. Then it would be plus, that look like 2, close the bracket, plus product of the leading, minus 6, plus 3. Then I just need to add. It really comes down to adding now. So now 6 minus minus 6, that's 12. Then I have minus 4 plus 2 is, that's what, minus 2. And minus minus 2, that's plus 2. All right, and here I have, something looks a little off right here, because I thought we were supposed to get 5. We're supposed to get 5, so I just need to check back one more time, because this don't look like it's going to give me 5. Using row 1, 1, 1, 1, 2 minus 3, 2, minus 1, minus 3, minus 2. So it would be minus 3, 2, minus 3, 2, 2, 2, minus 1, minus 2, and then 2 minus 3, minus 1, minus 3. Product of these is 6, minus minus 6, that's 12. Product of these is minus 4, minus 4, plus 2, that's minus 2, and minus 2 times minus 1 is positive 2. Here now, product of these is minus 6. Oh, it's minus 6 minus 3. That's what we did off there. This would have been 12 plus 2 minus 9. That's 14 minus 9, which is 5. So that's the proof right there. That is 5. That's part A. Nice, easy, and soft. So we get the 5 now. So good with that. The next part says matrix A is changed to form new matrices B, C, and D. Write down the determinant of each of the new matrix, giving a reason for your answer. It says in any case, matrix B is formed by interchanging row 1 and row 2 of matrix A, and then interchanging column 1 and column 2 of the resulting matrix. So what I'm going to first do is interchange. I'm going to interchange A and B. I'm going to interchange row 1 and row 2. Let's interchange row 1 and row 2. So this is matrix A right here. All right, so this was part 1. That's matrix A. And then I'm going to interchange row 1 and row 2. That would become 2 minus 3, 2. This is 1, 1, 1. Then this is minus 1, minus 3, minus 2. And then they said that we're going to interchange the column 1 and the column 2. That's what they said. Interchange column 1 and column 3. Then interchange column 1. And then interchange column 1 and column 2 of the resulting matrix. So now I need to interchange column 1 and column 2 of the resulting matrix. So I'm going to change the color right here so it look a little bit better. So interchanging column 1 and column 2, this would become minus 3, 1, minus 3. This would become 2, 1, minus 1. And then you'd have 2, 1, minus 2. So stay so now, boom, bang, and work out determinant of this, because this is now matrix D. So now we can tell them, so the determinant of matrix D is going to be, I'm just going to look at it and do it. It's minus 3 times these two. That's minus 3 times minus 2. Minus 1 is plus 1. Close up that. Then this one is now minus 2 times in bracket. This cross out this row and column, it's 1 times minus 2, which is minus 2. Minus 2 minus 3 is plus 3. Close up that. Then last one now is plus 2 times in bracket. Cross out this row and this column, that's minus 1 plus 3. Minus 1 plus 3. Now we'll just put this in our calculator, but because we test with memory, we're not using a calculator. We Gucci around here, no calculator. This is going to be minus 1 times minus 3. Minus 1 times minus 3 is 3. Then minus 2 plus 3 is 1. 1 times minus 2 is minus 2. Then we have minus 1 plus 3 is 2. And then 2 times 2 is 4. So what we end up getting is 4 plus 3 is 7, minus 2 is 5. So notice that the determinant of B is still 5. Wow, that's crazy. So now they say row 1 of matrix C. Row 1 of matrix C is formed by adding row 2 to row 1 of matrix A. The others are unchanged. So what they want you to do now is look at matrix A again, and row 1 and row 2. Row 1 of matrix C is formed by adding row 1 to row 2. So we're going to add row 1 and row 2. So this one right here, so we're going to get a new matrix. I'm going to make the space down here. We're going to make a new matrix C by changing row 1. We're going to change row 1 by adding row 1 and row 2. So 1 plus 2, 3. 1 plus minus 3, minus 2. 1 plus 2, 3. They will leave row 2 as it is. 2 minus 3, 2. Then you have minus 1, minus 3, 2. Now we need to find the determinant of matrix C. Now the determinant of matrix C is going to be 3 times. We're just going to do it in one step. Cross out the row and the column with 3 in. Cross out this. Cross out this and this. Sorry, just look at this here. We're gonna cross out this and this. That's the row and the column 3 is in. So that is gonna be left back with minus 3 times 2, that's minus 6, plus 6. So it's gonna be minus 6 plus 6. Close up that now. Then it's gonna be minus 2, which is plus 2 times, in bracket, cross out the row and the column here. Dum, dum, dum. We're gonna get 2 times 2, which is 4, minus 2, which is 6. That's 4 plus 2. Then lastly, we're going to cross out this row and this column. We're left back with minus 6 plus 3. So that is now plus 3 times in bracket minus 3. Wait, let me cross it out again. Oh, it's positive 3. It's positive 3 plus 6. And then we'll work out that and we'll get the determinant of C. So the determinant of C is, this is 0. This is now 6 times 2 is 12. That's 12 plus, this is 3 times 6 is 9. 9 times 3 is 27. And that overall is, that overall is 39. The determinant of C is 39. So just to write them on the paper here so far, realize so we get right, so we'll get this one to be determinant of 5, this one to be determinant of 39. Now them say determinant of D is formed by multiplying each element of the matrix by A by 5. So if we multiply everything by 5 to get matrix D, let's write matrix D on a new page. Matrix D is a whole heap of work, you know. Matrix D is going to be multiplied everything by 5. We're going to have 5, 5, 5. Here, so we're going to have 10 minus 15, 10. Then down at the bottom, we're going to have minus 5, minus 15, minus 10. And then now we need to just find the determinant of matrix D. The determinant of matrix D is row by column. That's going to be 5 times the determinant of minus 15 times minus 10, that's 150. And this is going to be plus, like 150. Just want to make sure I do it right. Yeah, that plus 150. Then it's going to be minus 5 times in bracket. Cross out this row and this column. I get minus 100 plus 50. So that's going to give me minus 100 plus 50. And then finally, this one going to give me cross out this and this. That's going to be minus 150 plus 75. This is plus 5 times minus 150 plus 75. All right, nice. So now we just need to hurry up and work this out. So what we're going to get is the determinant of the matrix D is equal to 300 times 50 times 5 is 1500. This is now minus 50 times 5, that's minus 250. Then we have minus 75 times 5, and I think that's minus 350. That's going to be minus 600. Minus 600 from 1500. And if you minus 600 from 1500, you get 900. That's the determinant of D, 900. So realize multiplying every element by 5, that made the determinant become 900. Is there a relationship that we can realize? 5. How many elements are here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm trying to realize what's the relationship between 5 and 900. It's trying to postulate something, but we can ignore that for now. Now this right here so says, given that this is a matrix M, find what is A times M. So let's copy what M is. This is a matrix M right here. Take that to the white screen and we shall have some fun. Let's write it as a matrix. All right. This can work so far. Just push this over a little bit. Yeah, that can work. And this is the matrix M. All right, so if this is a matrix M, we need to know what is A times M. So of course, we know we're going to multiply them. So we're going to multiply A times M, and multiplying A times M, let us do that. What was A again? A was 1, 1, 1, 2 minus 3, 2. Just going to write it down. A was 1, 1, 1, 2 minus 3, 2. Then I think it was minus 1, minus 3, minus 2. So that's A. They were multiplying it by M, which is 12, minus 1, 5, 2, minus 1, 0, minus 9, 2, and minus 5. Multiplying these two matrices, you know, we'll go row by column. So this is going to be equal to, now this time this is 12 plus 2 is 14. 14 minus 9 is 5. We'll go row by column, that's minus 1. Minus 1 plus 2, this is 0. Row by column, we're going to get 5, 0, minus 5, that's 0. Row by column, we're going to get 24, minus 6, minus 18, that's 0. I catch a pattern already. This is 5, 0, 0, 0, 5. So if you want to write it even better, you can say that matrix M is 5 times the identity matrix. So it works out really easy. That's all. So you can tell them, say A times M is 5 times the identity matrix, 5i. So hence they want us to deduce, is it A inverse or M inverse? Let's look back. Deduce A inverse. So to find the inverse of matrix A, all right, we can realize, so therefore, that A inverse is going to be equal to 1 over 5 times the matrix M. That's going to be A inverse. So since A inverse is 1 over 5 times the matrix M, we can write that A inverse is going to be equal to 1 over 5 times this matrix right here, 12 minus 1, 5, 2, minus 1, 0, minus 9, 2, minus 5. That's A inverse. All right, so this is A inverse now. All right, so it's just 1 over 5 times the matrix M. Dum, da, dum, dum, dum. Yep, we're not doing it yet. That's A inverse. Now the next part of the question says we're supposed to write the matrix AX equal B, right? This equation in the form AX equal B. So first thing I shall do is copy the equations and write it in that form. All right, so write it in that form, this equation, these three equations right here, boom and boom. These equations can be written in the form, this is really saying 1, 1, 1, 2, minus 3, 2, minus 1, minus 3, minus 2. Look at the coefficients of x, y, and z times x, y, z And that is equal to the result matrix given over here, which is 5 minus 10 minus 11. And you're done. This is it in the form AX equal to B. This is a A, literally that's a A. This is a X, and this is a B. Nice. Now it tells we say, show that X equal to A inverse of B. Now, that's easy. If you have AX is equal to B, then you can pre-multiply both sides by A inverse. So if I pre-multiply both sides by A inverse, I'll get A inverse of B, and I have A inverse times AX, A inverse times AX. But A inverse times AX is I. That's the identity I. This is going to be I. So this is now I times X is equal to A inverse of B. But remember that I times X going to just give you X. So that implies that X is equal to A inverse times B. X is A inverse times B. So that's it. Nice and easy, soft. That's that part right there. Now the next part is going to say hence find X. Then boring enough. Hence solve the system. Tell you. So then say hence solve. So since them say hence, I'm supposed to solve it. All right. So all we need to do is use the inverse times B. So all we're going to then tell them is that X, Y, Z is equal to A inverse that we wrote down, which was 1 over 5 multiplied by M, which was 12 minus 1, 5. 12 minus 1, 5. Go back from B here, so 2 minus 1, 0. And then right here, so was minus 9, 2, 5. Minus 9, 2 minus 5. And then this is being multiplied by B. Where is B? This is B. 5 minus 10 minus 11. So we're going to multiply them out now. I'll multiply them out. Let's see what we get row by column. Multiplying them out, we get row by column. This is going to be equal to 1 over 5 times in bracket row by column. 12 times 5 is 60. Then this is plus 10. 5 times minus 11, that's minus 55. Then this becomes 10 plus 10 plus naught or 0. Then the final row times this column, that's minus 45. Minus 20, then that's plus 55. All right, close the bracket. So what we're going to end up getting is now 1 over 5 times, this is now 70 minus 55, that's 15. This is now 20. This is now minus 65 plus 55, but minus 65 plus 55, is that 10? Minus 65 plus 55 is minus 10. So now if you take 1/5 of all of this, you're going to get 1/5 of 15 is 3. 1/5 of 20 is 4. 1/5 of 10 is minus 2. So that means that X equal 3, Y equal 4, Z equal negative 2. You can just punch that on right here, so, and tell them say X equal 3. 2 marks, them wicked. X equal 3, Y equal 4, Z equal negative 2. 2 marks for that? That's crazy. Now they say show that 1, 1, 1 is a solution of the following system. To show that 1, 1, 1 is a solution, right? To show that 1, 1, 1 is a solution, all I need to show is that it satisfies all the equations. If you look at it, 1 plus 1 plus 1, that end up equal 3. If you're looking at the second equation, what you realize is in the second equation, you get 2 times 1 is 2 plus 2 times 2 plus 2 times 6. Wait, 2 times 1, sorry, plus 2 times 1, because everything is 1. 2 plus 2 plus 2 is 6. Yeah, man. Nice. And then finally, the last row, we can state and realize that 3 times 1 plus 3 times 1 plus 3 times 1, that will equal to, of course, 9. Yeah, man. Oh, nice. What is this saying to us, guys? That's what they're asking in the next part. Hence, find the general solution of this set of equations. So, of course, let us kick this off. This is a very easy question. So after we reach here, so now we're going to have some fun. We're going to stay so now, boop, bop. All right, so I reach this nice part now. So we have x plus y plus z equal 3, 2x plus 2y plus 2z equal 6, 3x plus 3y plus 3z equal 9. We'll get to this stage now. All right, we'll get to this stage. All right, we'll get to this stage now, and we want to find a general solution. So what we're going to do is put it in matrix form or row reduce. Putting it in augment matrix, this would say 1, 1, 1, augment 3. This would say 2, 2, 2, augment 6. And then this would say 3, 3, 3, augment 9. So in order to solve this now, we know, say, of course, we need to just change out row 2 and row 1. So first to row reduce it, we need to write back row 1 as 1, 1, 1, 3. Then for change out row 2, we know so we can multiply row 1 by 2 and then subtract it. We can multiply row 1 by 2 and then subtract row 2 to get with 0 here. So by doing that, we're going to get 2 times 1 is 2, 2 minus 2 is 0, 2 minus 2 is 0, 2 minus 2 is 0. 3 minus 3, or 6 minus 6 can be 0. Then we can do the same here. So now if we get 3 row 1 minus row 3, that can just give a 0, 0, 0, 0. So now what we're going to have to do is since we not get nothing for z and y, we can let z be equal to t, and we can let z be t and y be equal to another real number s, and we have to tell them where s, and t is a element of R, right? So what that therefore means is if we call in zt and ys, we're going to end up getting the first equation. It is x plus y, where y is s, plus t is equal to 3. And so that implies that based on the number, whatever we choose for s and t, it's going to tell us therefore that x is just going to be equal to, x is 3 minus in bracket s plus t. That's your general solution. 3 minus s plus t. All right, so we're going to write it down, just to write it down, for writing it down, see? Right here, so see it here. You tell them, say, x equal to 3 minus in bracket s plus t, y is equal to t, and z is equal to s, something like that. Now, if you don't believe me, I'm going to show you. I'm going to pop out the calculator and show you. So, for example, if you were to give me a value for s and t, let's say they decide to take s as 3 and t as 2. Let's say you're calling ST and 3, 2, right? I don't know, I'm just making up some numbers. So let Y equal to 5 and Z equal 4. If Y equal 5 and Z equal 4, so X would be equal to 3 minus the sum of them there, 5 plus 4, which is 9, 3 minus 9. 3 minus 9 is negative 6. So look what I'm going to show you. What I'm going to show you now is if you take out a calculator and look on the first equation, type in X minus 6 plus minus 6 plus Y, which is 5 plus Z, which is 4, you're supposed to get 3. See there? 3. Try it now, second equation. 2 times X, which is minus 6, plus Y, which is 2 times Y was 5, plus 2 times Z, where Z is 4. You're going to guarantee you're going to get 6. See, there's 6. What that means is whatever you choose for Y and Z, right, you're going to get a corresponding X value, and then that would give you a solution. So a solution of this system is minus 6, 5, 4. You can even try another values, all right? So that's how you do this. This is a general solution over here. The general solution is right here. X equal to 3 minus S plus T, Y equal T, S, Z equal S, where you have to remember that T and S are just real numbers that you would choose. All right, nice. So that's it. That's the end of 2011. I really hope you had fun, and stay tuned for more. Make sure to subscribe, and all the best practicing for your exam.